We're taking a look at aquatic biodiversity and aquatic ecosystems. In the last podcast, we were looking at marine ecosystems, saltwater ecosystems that include oceans, estuaries, and coastal wetlands. And now we're going to take a look at freshwater ecosystems. These are incredibly important, especially for us here in the Great Lakes region, where we have actually 20% of the world's surface freshwater. So it's an incredible ecosystem, both economically and ecologically for us. Now you can classify freshwater systems as either lentic or lotic. Lentic systems are those systems that tend to be stationary, things like lakes, ponds, wetlands. And it's not that lakes don't have motion, particularly in our Great Lakes. We do have circulation in the lakes, but it's not a flowing body of water, so to speak, as opposed to rivers and streams, which are flowing. So those are lotic, and I think of locomotion to remember the idea of lotic systems being those systems in motion. Now, the Great Lakes are actually both. Because you have all of the stationary lakes of Superior, Michigan, Huron, Erie, and Ontario, but you also have the river systems that connect them, and then the river systems that also lead out to the ocean. And this is a great diagram of a profile that describes what the Great Lakes system looks like, where you have water that flows from Lake Superior to Lake Huron, but actually flows through a river, the St. Mary's River, which has a considerable drop in elevation between Superior and Huron, and that's actually why you need the Sulaks up in Sault Ste. Marie, so the ships can be lowered or raised to the proper elevation before moving on. From Lake Huron, water is going to be flowing between Lake Erie or to Lake Michigan. If it's going in the direction of Lake Erie, it's going to be passing through the St. Clair River and Lake St. Clair. You can see how shallow they are compared to the other Great Lakes. From Lake Erie, it's going to be moving eastward through the Niagara River over the Niagara Falls, and you can see the elevation change there, where it drops about 150 feet over the falls and eventually into Lake Ontario. And then from Lake Ontario, it's going to be moving out the St. Lawrence Seaway out to the Atlantic Ocean through a series of dams and locks as well, where you have a fair number of elevation changes as well. What is not on here is the fact that Lake Michigan also flows westerly through the Chicago River and out to the Mississippi River, and that's actually an engineering marvel. The Chicago River used to flow into Lake Michigan, but it now flows out of Lake Michigan and to the Mississippi. So if we take a look at inland lakes and large ponds, those types of things, you can break it up into four basic zones. There's the littoral zone, limnetic zone, profundal zone, and benthic zones. And these zones are analogous to the same types of zones that we found in the ocean, where you had the euphotic zone, the bathyal zone, and the abyss. Now in the littoral zone and limnetic zone, they're very similar, except they differ in their location. The littoral zone is going to be near the shore, where you have rooted plants, seaweed, you're going to be having lily pads, those types of things, and there's going to be a lot of biodiversity. There's going to be a lot of photosynthesis, high net primary productivity. The limnetic zone is also a photosynthetic zone, but it's away from shore, so you're not going to have the rooted plants. And in here, you're going to have larger fish because it's not as shallow. The profundal zone, which is going to be in the middle, has lower oxygen levels because it's too dark for photosynthesis, so you're not actually producing any oxygen. And you are going to have some fish in that zone, and they'll typically hide in that zone and then come to feed up in the littoral zone or the limnetic zone. The benthic zone is at the bottom, and that's actually the types of creatures that tend to populate down there. Your macroinvertebrate shellfish are going to be down there, and it's going to be high in nutrients because of all the dead matter that will sink to the bottom. Okay, and so here's a nice diagram that once again shows the different zones. Again, you can see the littoral zone with with the lily pads and the rooted plants. They're still actually in the water. The limnetic zone, which is in the open area, but also is a photosynthetic zone. The profundal zone, and then benthic. And oh, by the way, the limnetic zone would be comparable to the euphotic. The profundal zone would be comparable to the bathyal zone of the ocean, and it has a thermocline if the lake is deep enough. And then the benthic zone would be akin to the abyss. Now, just like the marine ecosystems, our freshwater systems provide a tremendous number of ecological and economic services. Climate moderation, once again, because water has such a high specific heat, it's going to heat up and cool down slowly, which means it's going to help moderate that climate. All nutrient cycles eventually flow through the aquatic systems, and in particular with the freshwater systems, you have a lot of exchange of nitrates and phosphates in the photosynthetic zones. Waste treatment is a big deal in freshwater systems, particularly because our wastewater treatment plants are on the rivers, and occasionally we'll be dumping any excess raw sewage during storms into the rivers. They also provide flood control, where all of our waters will be draining from the land into the waterways. And in fact, when we build shopping malls and housing developments and these types of things, without providing a way for the water to get back into the or to trap all of this water, we're going to actually have a lot of additional flooding. Groundwater recharge. Groundwater is a huge portion of the fresh water that's in the world. And so it has to get into the ground from somewhere. It is through the surface waters that eventually this water can find its way back into the groundwater. It is a very diverse habitat, and because of that has a tremendous amount of genetic resources and information for us to use. Of course, in terms of economic services, we pull a lot of fish out of our freshwater systems. The Great Lakes have been well known for the fisheries that we can manage. Obviously, the drinking water, irrigation water is a big deal, particularly out west, and it becomes a problem when we use too much irrigation water for the amount that's supplied. Hydroelectric power can come from freshwater systems through dams, as opposed to the tidal energy that's used in the intertidal zones of oceans. Transportation corridors, obviously the Great Lakes, which we call the inland seas, are a big deal, which also leads to the release of invasive species, and then for recreation and employment. Now, you can classify lakes in a couple of different ways. You have what are called oligotrophic lakes and eutrophic lakes. Let me show you a picture of what those look like first. Oligotrophic lakes are very clear, and they lack nutrients. They are going to be high in dissolved oxygen. Eutrophic lakes are going to be high in nutrients, and because of the output, they can have dead zones. But it's a balance with the photosynthetic productivity. If you have high photosynthetic rates, you're going to have large amounts of oxygen in there. If the algal bloom happens too quickly and there is a quick die-off, that can lead to dead zones. But in general, if you have high photosynthetic rates, you're going to be having high amounts of oxygen in there. It's going to tend to be murkier waters, high turbidity, meaning cloudiness, versus the oligotrophic lakes that are very clear. Now, people can cause eutrophication because of the nutrients that we actually dump in there. A lot of runoff from lawns, from agricultural fields, etc., bring a lot of nitrates and phosphates, and will cause the huge algal blooms that can actually encroach on the lakes, and eventually the lakes can actually fill in. That is called cultural eutrophication. Alright, so that kind of gives you an idea on the different types of lakes and the different layers that are in the lakes. In the next podcast, we're going to take a look at streams and some of the different characteristics of streams.